position time graph or displacement time graph, because we represent displacement by x and time to t, so it is also called xt graph. The another name of position time graph is xt graph. So from the name it is clear, then we take time on one axis and displacement on another axis. So in position time graph, we take time on x-axis and displacement on y-axis. So we have to relate these two quantities according to the motion of the object. So there are different types of position time graph. So first, when object is at rest. Okay, this is the time axis and this is displacement axis. So displacement and time. So if the graph between displacement and time is a straight line parallel to time axis. So what kind of graph is there? Straight line parallel to time axis. If the graph is drawn in the form of a straight line that are parallel to time axis, that means the object is at rest. Why? At 0 second, suppose the displacement is 10 meter. The displacement of the object is 10 meter. After 2 seconds, the displacement is 10 meter again. After 4 seconds, the displacement is same. After 6 seconds, the displacement is same. Suppose this duster is placed 10 meter away from me. So if at 2 seconds the displacement of duster from me is 10 meter. If duster is not moving, then the displacement remain 10 meter. So we can say that the duster is at rest with respect to me, with respect to surrounding. A straight line parallel to time axis represent the object is at rest, moving with uniform velocity. Okay, if we draw the graph between displacement and time, we are talking about the velocity. If the graph is between distance and time, we talking about the speed, uniform speed. So here we take displacement and time graph. So uniform velocity. What is the meaning of uniform velocity? We discussed in the previous lecture that if an object covers equal distance in equal interval of time, then the motion of that object is called uniform. So if an object moving with the uniform velocity, the graph between time and displacement of the motion of that object is a straight line but not parallel to time axis. The straight line with a slope. So what kind of graph is this? Straight line with slope. So this is a straight line also, but it is not parallel to time axis. The straight line with a slope. So the straight line in the xt graph represent the object is moving with the uniform velocity. How? We take 1 second interval, 1, 2, 3, 4. Okay. What is uniform? What is the meaning of uniform velocity? If an object cover equal displacement in equal time interval. So this is equal time interval, 1 second. Or this is displacement. So after 1 second, the displacement is 5. After 2 seconds, the displacement is 10. After 3 seconds, the displacement is 15. After 4 seconds, the displacement is 20. So these kind of 5, 10, 15 and 20. So first 1 second, after first 1 second the object covered 5 meter. In next 1 second the object cover 5 meter. Next 1 second object cover 5 meter. So object covers equal displacement in equal time interval. So this kind of motion is called uniform motion, or an object moving with a uniform velocity. Another kind of graph is if the graph is curved. This is a straight line, this is a straight line, this is a straight line parallel to time axis, this is a straight line with a slope. But if the graph is curved, then what types of motion it represent? If the graph is a straight line parallel to time axis, it represents the object is at rest. If a graph represent with a straight line with a slope, it represents the motion of an object with uniform velocity. But if the graph is curved, and what kind of motion is represented by a curved graph between displacement and time? So we draw number 3. When object moving with non-uniform velocity. If an object moving with a non-uniform velocity, the graph is curved. Any type of curve between the x and t. So if the graph is like this, so this is the displacement and time. So we can say that first 1 second the displacement is 10 meter. But next, this is equal graph. So next 1 second we can say that the object does not cover equal distance in equal time interval, because first 1 second it covers 10 meter. In next 1 second it covers only 5 meter. So this kind of motion of that object is called the object is moving with a non-uniform velocity. A curved graph between displacement and time is represent the motion of the object with a non-uniform velocity, or we can say that this is the accelerated motion. If the velocity is changed with respect to time, the change in velocity with respect to time is called acceleration. So these kind of motion is also called accelerated motion. Here the velocity changes. Here velocity is same every time, because velocity is displacement upon time. So what is the displacement? 5 upon time 1. So what is the velocity? 5 meter per second. If we want to take the time of 2 seconds, so in 2 seconds the displacement is 10. So 10 upon 2. 5 meter per second. So everywhere if we calculate the velocity displacement upon time, it is always remain 5 meter per second. But here the velocity of that object does not remain same throughout the motion. So the velocity is changed. So if the velocity is changed with respect to time, then these types of motion is called accelerated motion or non-uniform motion. So there are 3 types of xt graph. When the object is at rest, when object moving with a uniform velocity, and object moving with a non-uniform velocity or accelerated motion. So next topic we are studying in xt graph is slope. So what is the meaning of slope and what the slope represent in xt graph? So we study slope in xt graph. So what is the meaning of slope? So this is the slope. There is time axis, displacement, and this is the graph between displacement and time. We take a straight line graph with a slope. Okay, so what is slope? So the line inclined between the x and t, that is called slope. So this is slope. If we put an object here, an object moving fast, then the slope is larger. When the object moving slowly, then the slope is lower. We can see the slope in front of there is slope which inclined on the door, on the gate of our house. So and we can see the slope in park also. We can see the slope in the park. We can take a slide. So if the slope is like this, slope is like this, then if we put an object here, then object rotate, slide slowly. If we put an object here, then the object move fast. So this slope is less, this slope is greater. So how can decide which slope is larger and this slope is greater? So if we draw a line, a perpendicular on the time axis, so if we can consider this angle is theta with the time axis, if so this is base and this is perpendicular. So if we fix the base and increase the perpendicular, if we increase the perpendicular, so the slope is greater. So we can say that slope is directly proportional to, slope is directly dependent on the perpendicular. If we increase the perpendicular and the base remain constant, if we increase the perpendicular, slope increases. Now we fix the perpendicular and base decreases or base increases. So we change the base. So this slope is fixed. So we can put here the base increases because the base is previously the base from here to here, but if we increase the base, so this is the perpendicular remain fixed and the base increases. We can say that slope is decreases. When base increases, so slope is decreases. That means the slope is inversely proportional to base. So perpendicular upon base. Perpendicular upon base. And we know that what is the meaning of perpendicular upon base? In mathematics we represented by tan theta. Okay. Now here what quantity represent by the perpendicular? So this is perpendicular. So what is represented by the perpendicular? So perpendicular is represented by the displacement. So this is displacement. And what is represented by the base? So this is time. Okay. So this is displacement upon time. What is this? Slope. Because perpendicular upon base is slope. So displacement upon time. So we can represent x upon t. X is displacement, t is time. Or we know that displacement upon time is the formula of velocity. So this is velocity. Velocity is represented by v. So slope in xt graph. Slope in xt graph represent velocity. So what is represented by the slope in xt graph? So we can say that the slope in xt graph represent velocity. This is very important. Different types of question asked in examination on this topic. Suppose this is the graph between displacement and time. This is the graph of car A, car B and car C. So a graph of displacement and time represented of three cars, motion of three cars, car A, B and C. Examiner asked that which car is moving faster? Which car is moving fastest among three? So we can say that if the velocity is larger, the motion of the car is fast. So the velocity is represented by the slope. So which slope is higher, A, B or C? So we know that the slope of car C is higher in xt graph. So what is the slope? Velocity. So the slope is higher, that means the velocity of car C is higher. So car C moves fast. So car C moves fast among these three cars. So this kind of question can be asked through this topic. Next type of graph is velocity time graph. So after displacement time graph, we discuss velocity time graph. So velocity is represented by v and time is represented by t. So this type of graph is also called VT graph. So in VT graph, we take time on x-axis and velocity on y-axis. So we relate these two quantity about the motion of an object in a straight line. So we can show the relation between velocity and time of an object. So first of all, focus that here on y-axis, now it is not displacement, it is velocity. So think about the velocity. The velocity increases or decreases with respect to time. Now displacement is not here. So forget about the displacement and now thinking about the velocity, which are increasing or decreasing, which are variable with respect to time. So what is their types of graph are there? So first of all, what is a VT graph or velocity time graph? Velocity time graph represents the motion of an object and shows the relation between velocity and time. Okay, if the graph, first type of graph, if the graph is straight line, if the graph is straight line parallel to time axis, if a graph is a straight line parallel to time axis, what represented by this graph? What kind of motion can be represented by this graph? So first of all, I am asking that the object is at rest or motion. Okay, look at this graph and answer that the object is at rest or motion. So don't forget, this is not displacement, this is velocity. So 0, 1. Suppose this is velocity meter per second and the time is in second. So initially the object is moving with the velocity 10 meter per second. After 1 second, the velocity remain 10 meter per second. After 2 seconds, the velocity is 10 meter per second. After 3 seconds, the velocity is 10 meter per second. So from this graph, the object is at rest or in motion. So object has a velocity. So how can be is at rest? So the object is in motion and the velocity is constant. Velocity does not change during the motion. So we can say that first of all, the object is in motion. Object is in motion. And which kind of motion? If object is moving, then which type of motion is there? So object moving with the uniform velocity. Okay. Why uniform velocity? Because the velocity does not change with respect to time. So velocity is uniform during the motion, or velocity is constant during the motion. So we can say that the object is moving with the uniform velocity if the graph is a straight line parallel to time axis. In VT graph, specially focus that VT graph is there, not XT. XT graph represent the object is at rest. So second type of, if the graph is a straight line between velocity and time, this is time, velocity in meter per second and time in second. If the graph is a straight line with a slope, so what types of graph is there? Straight line with a slope. So these kind of graph in VT represent object moving with the non-uniform velocity. So object is moving or rest, object is in motion. And what kind of motion are there? The object is moving with the non-uniform velocity. So object is moving with non-uniform velocity.